Thanks. Hey, everybody. Bring my screen up here. Great. So the title of this talk is Good Architects Borrow, Great Architects Steal, which I stole from Pablo Picasso, apparently. And it's really sort of a confessional. Over the last few years, I was a founding member of our Postgres team. I helped with a lot of the early product work, a lot of the engineering. And some of the things we've done went really well, and some of them were not so good. So I wanted to share some of the lessons we learned sort of from an architecture perspective. But before we get into that, I'm going to say we're going to talk about the things I've stolen, the ways I've cheated, how lazy and intransigent I am. It's really a little embarrassing, but we'll come back to that. So how many people are familiar with Heroku Postgres? All right, that's great. So I'm glad to hear lots of you have used the service before. We have a very large fleet of Postgres databases that we provide to the world. And our mission as an organization is to provide just one slightly less horrible database experience that a developer can maybe get their job done a little better. It's no secret that historically working with databases has been sort of like the really hard, crunchy part of building an application. And I know from the old days it was really dark days in the 90s when you'd have to get on the phone with a DBA and ask them to make you a table, and it's just your DBA comes around and thumps on your desk and demands to know where the schema is, and you're like, I haven't even written the app yet, and it's been hard. And so what we've been trying to do is basically make that experience painless. And so the most important things to us are your relationship to that data and making that as painless and seamless and transparent as possible. So we've built tooling to help you understand the performance, tooling to help you interact with the data, ways to share data with your colleagues. And really, it's just about reducing all the barriers to working with data, which is great. It ties really nicely into Hillary's talk earlier. But I want to talk actually about the architecture of this system and sort of what our objectives are in building it. And so the history is that in the very early days of Heroku, we had one server. And the Postgres ran on the same box as everything else. And it's a minimum viable product. You ship it. But as time went on, kind of the increasing burden of sort of our ad hoc way of managing these things became problematic. And I joined the company about 4 years ago. And we'd kind of reached a breaking point. And so we said, OK, look, we're introducing this new add-ons program, and let's see if we can make the Heroku Postgres service a part of that add-ons program. And from then, and ever since, Heroku Postgres has been kind of a proving ground for a lot of Heroku technologies. We were one of the first apps on the platform to run workers, back in the day, different process types. One of the first groups to run Cedar and the sort of polyglot platform that Heroku is today. And we're currently rolling out very large-scale Go infrastructure, which is something that we're not formally supporting externally yet, but it's something that we're really excited about. But again, all of this is basically not about architecture. So let me talk about what we're trying to do. What we want to do is offer a database that works. That means you never lose your data. It's as available as possible. And secondary to the first clause, because losing your data is worse than having it go down for most users. This is our trade-off. And we want it to be just a joy to work with. But the ability to deliver value to our users is something that is really important to us, and we're willing to make certain trade-offs on that, as long as we can sort of encompass the risks of change to a small blast radius, so to speak. And so that's been a conscious choice with us. And so what we do is we say, look, as long as your database is up, we're willing to tolerate a bad deploy to the APIs and have to say, look, we're really sorry you tried to console into your database and it didn't work. And so in any sort of real-world engineering system, you make those trade-offs. And so I'm going to talk a little bit about some of the ways that we've built this. And so this is not a product talk, and it's not an engineering talk. I'm going to try and stick as close to the architecture of the service as I can. So my first crime, stealing. I have a background in the games industry. And so we went through a lot of different kinds of things early on. And Heroku, we really kind of embraced this Dieter Rams philosophy that everybody in Apple has sort of embraced the 10 design principles. Good design is innovative. Good design is honest. All these great things. But we're not going to talk about that. The problem with German design is that good design tends to be really fragile and expensive and go wrong at 3 in the morning. Instead, when we're talking about the architecture of the service, we like to think like Russian design. It should be dragged through the snow, fixed with a rusty nail, and keep on working. So one of the best things that I ever stole, and I can't really claim any credit for genius in finding this, it was just fortunate luck, was we kind of had this insight that if we could make our databases behave kind of like Mario characters, that maybe we could get something done here. And what I mean by that is that in a video game, you have sort of a really simple loop, right? You kind of have a world of physics. This is sort of the classic video game model. You have your graphics world, your physics world, and your logic world, and each frame you update all 3. And so we said, well, what if we sort of treated our databases like they were these video game characters and said, well, we'll have a sort of a sensory world, and our databases have these weird senses like uppiness and rowiness and things like that. And then we also have sort of a thinking world. And so all of our databases and servers and all the other entities in our system follow this really simple pattern. And it looks kind of like this. So we have a universe of things, and this is obviously a little simplified, but it's basically accurate. And what we do is we have them all in a big queue, and a worker just pops one off the front, and it feels it. It says, how's it going? And then it thinks, and it goes, OK, based on what I just experienced, am I up? Am I down? Am I over my row limit? Whatever those issues are. Now what do I have to do? And then we take that and we put it back on the back of the ring, and you can just go around and around and around and around. And this is a really beautiful and simple interface because it gives you a very flexible way of modeling real-time entities in the world. We use this not just for servers and databases. We use this to model all kinds of sort of availability incidents. So like, if your database is down, we spin up a little one of these entities in our world, and it goes, OK, is the database back? OK, what do I try next? OK, I'm stuck. Call for help. And so this all kind of fits together, and it's a beautiful hackable system. So a fairly rudimentary but typical kind of sense or feel, as we call it, we'll say, OK, well, let's check if the database is up, and then see how many rows it is. And every time you sort of iterate through, you always go back and check this same thing. And then every time after that, you sort of think. So here's an example of a state. So if I'm a database and I'm available, and then I'm not up anymore, I'm going to transition to offline. If my number of rows is over 10,000, then I'd really like you as a user to start paying for the service. So we're going to create an incident called too many rows, which is going to send you a little warning that you're sort of abusing our free service. And this has been a great pattern for us. And it comes with a really sort of happy accident, which is this notion of persistence. And I don't mean persistence in the database sense. I mean like the damn thing just will not give up. And if you have sort of come up in this cloud infrastructure world, you may be familiar with the fact that eventually consistent is another term for inconsistent. And so oftentimes when you're trying to perform an operation, it pays to just keep doing it. If the server won't stop, just keep asking. Just keep knocking on that door. And then when it finally does stop, you can go on to the next step. OK, so that's state machines. Now I want to talk about how I've been cheating at my job for years, and how I would encourage you to cheat as well. We live in this world where there's so much we need to do. We have so many responsibilities. Running a business is hard. Operating your software is hard. Deploying things is hard. Building things is hard. So why not just let somebody else do that job for you? At Heroku Postgres, we are a data platform. We're trying to make data better. We don't need to be the best at non-data related things, and we try and outsource that as aggressively as possible. We live in this great time right now where there's this ecosystem, and leveraging that ecosystem gives us focus. Right? This really lets us concentrate on what we're best at. We put almost all of our engineering time into making your databases work. And that gives us this leverage, which is we can say, as new services come online and new providers and new technologies enter the market, it's really easy for us to take advantage of them because we can move quickly, adopt them, try them, experiment with them, and then ultimately either bring them into production or move on. So for example, email, there's a provider for that. Exceptions, we've got a provider for that. pager rotation, provider for that. Redis, server racking, application runtime, performance insight, our dearest friends here from New Relic. But all of these providers, SendGrid, PagerDuty, everybody else, have really helped us to build our business by keeping us focused on the task at hand, which is making your database great. In fact, we have at Heroku a whole massive ecosystem of providers that you can plug into your application. And we internally, when we build our services, make heavy use of that. So I've been accused of many things. Laziness is one that I certainly will cop to. We have a lot of servers, and I won't say exactly how many, but it's enough that when we call Amazon, a real person answers the phone very quickly, which for the first few years was a real sticking point for me, let me tell you. And the more servers you have, the more you realize how much you hate them. They're awful. They're these like heavyweight things that like people used to give personalities to. They're these, they fall over and go bump in the night. They're hard to replace. You put data in them, and then you have to go back and get it. Like for people who run a database service, I'm really obsessed with like statelessness. And our goal ultimately is to have like the world's first stateless database service. So people often say, okay, we've got all these servers. Do you use Chef or Puppet to manage them? So I've added this Chef Puppet here. Because we don't use either. We actually use a very old-fashioned sort of traditional interface, which is when something goes wrong with the server, we just give it the old Yeller treatment. Sorry. And this is incredibly powerful, right? Like, we live in a world where people need to change their thinking from treating servers as being sort of things that have character and personality to a world where these are disposable. This is maybe belying my green creds here. I'm kind of get in trouble with the recycling police for this. But I would encourage you, if something goes wrong with a server, just throw it away, right? Like if your light bulb filament burns out, you don't get in there and take the light bulb apart and try and wire up a new one. You just chuck it in the bin and put in a new one. A light bulb costs you $2. A server costs you $0. We live in a world where racking these things is free. You only pay for what you use. So why would you ever go in and try and fix one, right? The right mentality to have around these things is that you are running an assembly line. If something is wrong, you might go in to look at it, but you're really just doing a post-mortem, right? You're looking at it and saying, what went wrong here? Why did this thing fall over? How do we keep it from falling over like this in the future? And then you just fix that assembly line and we roll out again. And this is great because it means that not only are we rolling things out continually, we're also concentrating the entropy, the change, right at the head of that process. So things that are out there and deployed in the world, they're cool, to think about it in physical terms. They cool off and they kind of sit. They're stable. So we can move really fast and we can ship a lot of features and we can make changes because we're only exposing a very small number of people to risk. And we find that generally, people are very risk tolerant with things that are very new. And don't get me wrong, we don't do crazy things and that we think will risk your data. But if you're running a Heroku Postgres database, for the most part, we leave it alone. We try and never sort of warm it up. So this comes to kind of our principle on server management boiled down, which is maybe a variant on the KISS principle. Don't just keep it simple, stupid. Keep it simple and stupid. Every line of code that you put on a server that you wrote is one that is going to bite you. Every piece of code that you write has bugs. Everything. It's not any good. Just embrace it. It's fine. We're all like this. The key to sort of high-velocity software is that you need to be able to adapt quickly to changing circumstances, new requirements, discoveries of problems. And if you're tied to this sort of like heavyweight, oh my God, we need to roll this out to 5,000 servers in the next hour kind of problem, that is really going to keep you from getting work done. All the parallel distributed shelves in the world won't solve this for you. And so what we've tried to do is say, look, all of these boxes that run Heroku Postgres, they're really, really simple. We keep them just as close to stock as we can. And the way we manage them is actually from the outside in. So the only software that we have running on those boxes, as much as is sort of possible, is Postgres itself. Now, there are some exceptions. We have a daemon, basically, or a tool called Wally, which handles archiving all of the write-ahead logs to S3, but this is kind of down in the details. The principle is really simple. Don't put software on servers. They're heavy and break a lot, and you don't want to have to deal with that. Instead, keep your software somewhere that's stateless. We use Heroku for fairly obvious reasons. I love working on Heroku. Actually, one of the greatest perks of working at Heroku is having unlimited Heroku access. And we've really embraced this model, and it lets us deploy fixes and changes quite quickly. So this centralized control principle we have, in the early days, we would put agents on these boxes to sort of let you drive them. And I really feel sort of embarrassed to admit this, but like we don't use Chef or Puppet, we don't do any of that either. We've adopted a method for control which is nothing to install. It has a really well understood security model, and it's easy to make changes. Basically, we just SSH into the box automatically. This SSH, using SSH as a control protocol has been an incredible advantage for our development velocity. And this was really surprising, because when we first did this, we were like, OK, we're really lazy, and we're just going to do this right now to get up and running, and we're going to come back and fix this. But as the years have gone on, this has just been an amazing source of leverage for us. So take this sort of like simple check here. This is, again, kind of a sketch. So what we're saying is the server up? OK, well, in a timeout, SSH into this host, and then run a command, echo alive, and then if that returns, then we're OK, and otherwise we're down. Let's say that I decide that I don't want it to be echo alive, I want it to be echo 1, or maybe I want to do something clever with return codes. In a traditional sort of agent environment, once I make that decision, now to actually roll that out to the fleet means going into all these boxes and changing state on the box. I'm touching the box, I'm heating it up. There's a chance that I'm going to cause a regression and I'm going to break something. Don't do it. Outside in, right? The only thing that we install is that Postgres service, and everything else we inject through an SSH connection. SSH is not very performant, but it is extremely secure. It has extremely well understood memory and CPU usage. It's light. It doesn't leak and then crash. It works, basically. And we all rely on it to do our human jobs. At Heroku Postgres, we've found that relying on it for our machine automated jobs is really effective as well. And I'll make sort of a brief sidebar, which is to say that if you want to go down this road, I would definitely recommend early on automating key rotation and looking into connection pooling, because obviously the cost of opening up one of these connections for everything all the time gets quite heavy. All right, so now I'm going to move on to my sort of fourth crime against humanity, which is intransigence. I like to call this out-factoring rather than refactoring. And the idea is basically when you find a service and you're saying like, oh God, we got to fix this, we got to rewrite this, the best way to do that is to take that service and pull it out. This is known in the sort of software-oriented architecture world as service decomposition, but I don't really like that name, so we're just going to call it out-factoring here. So this gives you a lot of benefits. The first is that as your engineering team scales, again, it's about sort of concentrating that heat of development into places where it will do less damage. Every change you make sort of introduces uncertainty. So you want to try and isolate the blast radius of problems as best you can. So one of the benefits to taking your sort of monolithic service and splitting it into smaller parts is you can say, OK, on each side of this API, there's a contract that we'll respect. No one's going to reach across and monkey around in your database. No one's going to share that God model too far, right? You kind of have that nice isolation. Some other really good benefits as well, for example, you can take a code base that you've written in Ruby, which was fine for when you had 100 servers, and you can rebuild it in Go, which will scale substantially further. You can take the experience that team members have in a different programming language and leverage that. And not only that, when you put things into that sort of service-oriented architecture, when you out-factor, you can say, these people understand this software the best, and you really create sort of a locus for understanding. And that's incredibly valuable as well. This also enables a pattern that I like to call the sidecar, which is that as you're building out these new services, if you're having success, you're scaling really quickly, and things are changing. And in the old days, when you push bad code, it would just go bump, and you'd email like 3 people, and then it's cool, right? No big deal. Nowadays, when we break something, it can cause a lot of hurt. So what we do is this sort of sidecar technique. And what we say is, OK, well, we can actually bring this new version of a service up online adjacent to the main production service, and we'll start running a full production workload through it. And we'll do that for a period of like weeks or even months as we gain operational confidence with it. And then as you become comfortable with this thing's sort of failure modes and sort of fault tolerance, you can start to blend traffic over to it. I believe this is actually a Russian motorcycle here, just to be clear, because it's very much sort of this like street fighting, keep it simple, stupid design. And if you keep at this for long enough, you'll take that monolithic application and you'll start to break it up into more and more pieces until what you have for your sort of from a user perspective single product is actually a constellation of applications which are communicating over robust, well-designed APIs and which have beautiful clients which, when your front-end people push bad code, won't cause regressions in your back-end, if you're lucky. I will say, in all fairness, that has anyone here ever read The Architecture of Open Source? A couple of people. It's by and large kind of a tedious book, but some of the authors are really quite brilliant. And there's a great section in that book by the authors of BerkeleyDB, which I highly recommend. And one of their key learnings, which I want to share with you, is that if you begin a refactoring, you really have to see it through. If you start down that road and you get yourself caught halfway, how many people have a half-finished refactoring in their code base? Oh, come on, be honest. I don't believe anyone who didn't put their hand up. Maybe you don't code. That would be fair. I'll confess that about a year and a half ago, we decided to separate out the responsibility for running the Postgres clusters for the responsibility for delivering the actual databases and managing credentials and these kinds of things into separate applications. This is a really great move for us. We'd be really happy with it if we'd finished. But what happened was, after we deployed that service, we brought them up in that sidecar mode. And as we were working to bring things across, Amazon had one of those massive, oh my god, we just lost all the disks in a data center style outages. And so we spent the next few days just cleaning up after that and bringing people back online and squaring things away. And then after that, we said, OK, we're going to come back and finish this later, but right now, we need to drop everything and focus on making sure we don't get bit like this again. And we did, and we won't. Knock on podium. But to this day, if you go look in the Heroku Postgres commands inside our command line tool, you'll see that actually there's this still weird sidecar thing happening where certain plans are going to one API and certain plans are going to another. And this is a wart on our architecture, which just drives me crazy, but it is what it is. So we're here at FutureStack, though, and I'd like to kind of bring these things back together to talk about sort of what I think the FutureStack is. But before I do that, I just want to recap quickly these architecture lessons we learned. First, the state machines. They're not technically FSM sort of mathematically legitimate state machines, but these things work amazingly well for operational tooling, for monitoring real-time services, and for adapting to change. They're incredibly hackable, and they're incredibly comprehensible. New people can come onto the project and just read these state definitions, and they work really well. The only words of caution I would give you are, in the parts where you're sort of shuttling around the state machine, try and do as little work as possible and try and keep it as idempotent as possible. If you can enforce that, so much the better. Second, you've got a cloud service ecosystem. We're better than you at running Postgres. New Relic is better than you at doing performance monitoring. SendGrid will deliver email so much better than anything I've ever stood up, right? PagerDuty is going to actually wake me up in the morning, unlike the gross SMS to Twilio to like my answering machine pipeline that we had before. Take these people who have expertise and lean on them. It's great. We have gained so much velocity and gotten so much further, so much faster by doing this. I cannot recommend it highly enough. If you must have servers, which I would heavily discourage, keep them as dumb and as simple as possible. Have a consistent interface. Don't touch them. Leave them cool. The less you sort of warm these things up with your hands, the more likely they are to be all right. And last, practice this out-factoring as often as you can. It'll help you scale your applications and your team. So I would say that the future stack is already here. And so I'm just going to call it the now stack, so there. And the old stack was LAMP or LAP or whatever we had in those bad old days. But the new stack's not about a language. The new stack is about building polyglot applications which the right parts of your code are written in the right languages for the job. Whether you're building the next Twitter or the next data service or the next infrastructure, whatever that is, you're going to need a lot of different tools in that toolbox to do the job well, and the people who embrace that are going to move fastest. Lean on your service ecosystem. This is the same story again. There's a lot of people out there who can help you do your job better. Don't try and be an expert at everything. Every day that you spend working on something that isn't part of your core value proposition, that is time that you can't get back. That is undifferentiated. If you can put that same day into making your service different and better than anybody else at what you do, that's how you win. And finally, the API-driven design, I probably don't need to proselytize this here, but we've seen so much benefit from taking those sort of front ends and pulling those out all the way and making them their own standalone apps. Today, the Heroku Postgres service, all of our sort of core crunchy logic, which used to be in Rails apps, that's all pulled out now, and that's Angular and Backbone, that's command line tools that speak to the same APIs as everything else, and even our admin dashboards are all pulled out and speak over the same APIs as the actual services themselves. It's more robust, it's more maintainable, and it is easier to fix when things go bump in the night. And that is sort of what I wanted to tell you about. I'd be happy to take some questions.